In the previous two videos in this series, we have been creating connections between models in MagicDraw and Jama, and using them to create a unified system model distributed across these tools. In this video, we will show several options for tracing and visualizing these connections. In the UAV model we have been working with, there are multiple connected tools beyond Jama and MagicDraw. The Connection Summary tab on the Syndeia dashboard provides a tabular view of all these intermodel connections. That is, the connections between models in different tools that Syndeia manages. According to the display, there are 87 stored connections. The Connection Summary has useful tools for searching, sorting, and filtering the rows. For example, searching for Jama shows just the connections to Jama. We can also export the table as an Excel file. An alternative view of the intermodel connection is a chord plot, which can be launched from any element in the MagicDraw model or Syndeia dashboard by right-clicking and choosing Syndeia View All Connections. This opens a plot in your default web browser, where the circles on the periphery represent elements in MagicDraw, Windchill, Simulink, GitHub, Jira, Jama, and MySQL. And the chord lines represent the intermodel connections. Like the Connection Summary table, it provides search and filter capabilities, for example, turning off all Jama connections. The chord plot provides a quick visual display of what tools are connected and how densely. In addition to the intermodel connections, there are intramodel connections, for example, within the SysML model. A quick scan of the MagicDraw diagrams shows compositional relationships between blocks, containment relationships between requirements, and satisfy relationships connecting blocks and requirements. These also form part of the total system graph, and Syndeia can display these connections as well. For example, if we right-click on the flight software block in the SysML diagram and choose Syndeia View Neighboring Artifacts Auto Layout, this shows the flight software block circled in red to indicate its starting point, plus its nearest neighbors, a GitHub file, a SysML block representing the flight controller, an electronic component the flight software is allocated to, and a SysML requirement, autonomous functioning, that the flight software satisfies. Any of the neighbors with a green border can be expanded to show the rest of its nearest neighbors, if any. In the case of the flight controller, this includes a Windchill part, a Simulink block, and another SysML requirement that it satisfies, that is further linked to a Jama requirement. Expanding the autonomous functioning requirement shows a lot of new elements because it has a Jama connection and 8 sub-requirements, each with their own Jama connection. Such rapidly expanding models may be more easily understood in a tree format. If I choose the same block, right-click, and show Syndeia View Neighboring Artifacts Tree Layout, we can progressively expand and we see the same structure. tree layout, however, does not display certain SysML dependency relationships that flow upstream with respect to the tree. Zendaya 3.1 will be introducing its own backend database for managing connections. Check for additional videos demonstrating new queries for tracing connections across large graphs as these features become available.